Hello. So today I will be doing the solutions of I will doing solutions to the mechanics questions of 2019 INJSO paper. So this paper was I guess it was like there was a little bit of mechanics and then there was optics and electricity mostly. In the subjective part, I think there was a question from heat for 10 marks. So you can do that later. But now I'll be doing the mechanics. And why I'm only having is the 2019 paper is because I forgot to download the other paper. So sorry on my behalf. So let's start without wasting any time. Also, your NSCDS is over now, so I will say that just do PYQs because like INJSO PYQs are anyways of very high level. Oh, sorry. Okay, let's start the first question of 2009. Actually, not first because I messed up the order, but still. Okay. A river is flowing at 4 km per hour from west to east. So the river is flowing like this. Two swimmers P and Q can swim both at 2 km per hour in still water. So we are given their velocity with respect to the river. Okay. With respect to the ground, it will be the river plus their velocity in still water. The minimum time in which it is possible, sorry, minus the river. Actually, it's, yeah, so, in which is it, in which it is possible for the swimmers to cross the river is t minimum. So obviously t minimum we know from relative velocity that for t minimum you have to put all your strength. तो आपको पूरी ताकत लगानी होती है और स्ट्रेट लाइन में जाना होता है तो आप टी मिनिमम अचीव कर पाते हो तो वो दिया हुआ है कि मतलब बोला कि मिनिमम टाइम जो होता है बोथ ऑफ देम स्टार्ट स्विमिंग फ्रॉम द सेम पॉइंट ओ ऑन अ बैंक ऑफ द रिवर इन डिफरेंट डायरेक्शन शोड द पॉइंट एक्स इज डायरेक्टली अक्रॉस फ्रॉम द पॉइंट ओ सो ये सीधा है तो मतलब दिस इज 90 डिग्रीज ओके so this is a option elimination question so p will reach a point x at in t minimum q will reach in t minimum p will reach a point somewhere east of x in t minimum q will reach a point somewhere east of x in t minimum. So T minimum is given here, which is important later on. Firstly, we can see from here that it will not reach a T minimum. Why? Because because when you see when you take components, obviously this is theta. So this is let's say P's velocity is Vp. So this will be Vp sine theta. This will be Vp cos theta. So a time is given distance upon the velocity in the straight line. Okay, so it is gonna be Vp cos theta. Now obviously we know that this theta value it's smaller than 90 degrees, obviously greater than 0 degrees because we can see from here. So it is smaller than 90 degrees from the normal, from the vertical, sorry. So we can see that the cos theta value will be less than 1. So there will be an integer here which will be, so the t will increase. So it will not reach a t minimum. Okay. So that is how we eliminate this option. Second option is Q will reach the point X in T minimum. Obviously, if we can't reach, then how will Q reach? I mean, Q is trying his best, but the velocity of the river is just too much. So we know from a relative velocity that there will be a shift. So this distance that it will shift, it is called shift, like literally shift. Okay. So this velocity is V Q with respect to the river. It's given 2, and this is 4. This is 2. This is 4. So this will be the velocity of a q, okay, as seen obviously from the ground with respect to the ground. So there will be a shift, so it will not reach in t minimum. To reach in t minimum, it has to go in the straight line only. Okay, so this is also wrong. Okay, p will reach a point somewhere east of x. This is correct, right? It will reach somewhere x, but it says in t minimum. Now, if it was written it P may reach a point, then it would be correct because we don't know if it could literally be here or here somewhere, right? In T minimum, but Q will always go to the right, so it will always be east of the point X. Obviously, because the velocity of the river is more than velocity of Q with respect to still water, so it will obviously go where where the current is, where the river current is flowing. So this is obviously wrong. It would be correct if it was just written east of x may, or like it was written may reach somewhere east of x in time t minimum, then it would be correct. But it's written will, so it's wrong. Q will reach a point x somewhere, a point somewhere of x in time minute t minimum. This is correct. So we did one INJSO question. I would say it's a pretty easy question, but like it's of relative velocity. So obviously you can see that the paper is not based on ninth and 10th curriculum, which obviously we know, but like still it's written on the side. Okay, next one. Oh, okay, I kept some space for doing the question. Good. Okay, next question. So this is a question from kinematics. A particle, sorry, a particle is traveling with uniform acceleration of magnitude a during successive time intervals delta t1, delta t2, delta t3. Its average velocities are v1, v2, v3. Okay, so let's just draw a rough figure. Let's say this is till t1. Sorry, this is till t1, t2, t3. Here its average is v1, v2, and v3. Now, one of the first things I saw actually after doing this question, a lot of people could have made mistake by choosing the first option. Why you might say? Because like you might say acceleration is equal, right? So delta v upon delta t is equal. So this is given delta v2 minus v1 and t2 minus t1 is equal to v3 minus v2 upon t3 minus t2. This is correct, right? Right? No, because this is actually the average velocity which is given and not like the velocity. So velocity can change. It's just the average velocity in that time interval. Okay, so that is why A is wrong. So if you want explanation, okay, I just give the explanation. But okay, so this question is also something where you might have to put a lot of uh, options, right? So let's start like that. So we are given this is say v1 is obviously the average of this time interval, which is t1. Then for t2 the average is v2, and for t3 it is v3. We know this. So now we can let's say the velocity at this point was x, and here it was x dash, here it was x double dash, and here it was um, x triple dash. Okay, dash dash dash. Okay, so now we can say that from v is equals to u plus at, obviously the first equation of motion. So we'll obviously say that this is v. So x dash is equals to u, which is x, plus a into t, which is delta t1. Obviously a remains constant, so it will not change. So we'll make equations like these, so we can check later. Okay, now x double dash is obviously the same pattern. We get a delta t2, right? So obviously this is going to be this. We are doing from this to this. So from point B to A, this will be the speed. Yes, okay. So now let's just put the value of x dash here. Okay, so we'll get x double dash. So if we put the value which we just got, let's say this is equation 1, this is equation 2. So let's put the value of equation 1 and equation 2. So we will get x dash is x plus a delta t1 plus a delta t2. So that is x plus a delta t1 plus t2 delta t2. Okay, so we got the value of x double dash in terms of x and a. So we can see that there can be a pattern like this. So x dash is also, we have x and a. So we can later on, like we can just eliminate them by subtracting each other. Okay. Now for x triple dash in the same manner, you will get x plus a into delta t1 plus delta t2 plus delta t3. You'll get it in the same manner. Okay. Now, what else do we know? Because the acceleration is constant, we can say that this velocity plus this velocity will be divided by 2 will be v1, because it is the average velocity and the acceleration is not changing, it's constant. Okay, so the velocity curve would be like this, right? V versus t, because the acceleration is constant. Okay, so we will say that the v1 is equals to x plus x dash upon 2, and v2 is equals to x dash plus x double dash upon 2, and v3 is equals to x double dash plus x triple dash upon 2. So we now have this. So we have all this data. Now we can put this and simplify it. So let's do that. Actually, let's go according to the options. That will be, I think, easier for us to. So if we do that, Yeah, let's calculate for B first because it's like the only option with this. Obviously, we know this is wrong, so we'll try this one. V2 minus V1. Now, V2 minus V1 can be written as X double, see from here, X double dash minus X dash upon 2 minus, so this will be minus, and V1 is obviously X dash minus X upon 2. So then we will get, sorry, this is plus, yeah, this will be minus. So we will get, this is not that clear looking. Let me do it on the next page. So we get X double dash plus X dash upon 2 minus X dash plus minus X dash minus X upon 2. So we will get, this gets cancelled. So X double dash minus X upon 2. We take 2 common. Okay. So then we get this is the equation we get for V2 minus V1. Okay. Now let's put the value of this. So we will get, so do V2 minus V1 is gonna be, I think we calculate, oh we didn't calculate, okay. So we just have to do X double dash minus X. X double dash minus X, where is X? Okay, it's only X. So A delta T1 plus delta T2. So we get A delta T1 plus delta T2 upon 2. Okay. So this is V2 minus V1. Now let's do, so in the option it says we can interchange these values actually. So here we'll get T on the other side and this on the other side. I think you can see from here that T is like, on in all equations T is present, so maybe we'll get it later in our answer. Okay, so then we can see V3 minus V2. So V3 minus V2, if you have seen it, V3 minus V2, let me just clear some space. Yes, actually let me use a different color, this doesn't look that good. Okay, okay, so we'll use this one. Okay, so we know V3 minus V2, it will be X triple dash minus, um, first we like V3. V3 is X triple dash plus X double dash upon 2 because obviously acceleration constant, and V2 is, let's take minus common, so we say X double dash plus X dash whole by 2. So that will get us X triple dash plus X double dash minus X double dash plus X dash whole upon 2. So then we'll get this cancelled. So X triple dash plus X dash by 2. Now X triple dash plus, oh sorry, minus here. So X triple dash minus X dash is gonna give us this X triple dash, and this is X dash, here it is. So it will give, this will get cancelled. So a delta T1 will get cancelled. So we will only get, sorry, we will only get delta T2 plus T3 here. Okay. So if we go back, sorry. So we will here get a delta T2 plus delta T3 upon 2. So if we divide the equations, why are we dividing? Because it's literally divided here. Like if you transpose it, you will get V2 minus V1 upon V3 minus V2. So if we divide it, sorry, I keep going this way. Okay, so 1 second. I hope I am recording. Yeah, I'm recording. Okay. So if I clear some space, तो हम यहाँ पे बोल सकते हैं कि V2 minus V1 upon V3 minus V2, that will be equal, oh I calculated and I deleted it. Okay, sorry. So that will be delta T1 T2 plus T3 delta T3 upon 2 whole upon a delta T2, I think it was delta T1 plus T2, I don't remember now. I think there was, not sure, I think it was just this. If it's wrong we'll just say, okay, all by 2. So this cut, this cut, this cut, this cut. So V2 minus V1 upon V3 minus V2 is equal to delta T1 plus delta T3 upon delta T2 plus delta T1. Okay, so let's check our options. So if we transpose it, obviously we just transpose it. So V2 minus V1 upon delta T2 plus delta T3 is equals to V3 minus V2 upon delta T2 plus delta T1. This is our answer. So if we do that, delta T1 plus T2 delta T3 plus T2. Okay, they've interchanged this value. Hmm. Okay, somewhere maybe we've made a mistake. I'm not sure where. Oh, right, it's V2 minus V1, right? So iska, sorry. So this will just interchange. So it's just, sorry guys, my mistake. It was my mistake. So we'll just change this. This will be 1 plus 2. This will be 2 plus 3. And now we should be getting the correct answer. Yep, we are getting B. Actually, what I did was I divided V3 minus V2 upon V2 minus V1 by mistake. So, sorry guys. So the answer will be B. I would say it's a pretty easy question, but you can get confused by A if you haven't like done a similar kind of questions where like you take A magnitude is the same and then you say that average velocity is different. Okay, so I hope you understood this question. Key takes from this question, I guess you can say that V1 is equal to this starting velocity plus this ending velocity whole by 2 because acceleration is constant. And here also you can do the same logic, and then you add and subtract them, so you can eliminate this x variable because in the answer you can see only t and v, so you want to get somewhere close to that. So when we get close to that, we get this, and then we get this, and we get the answer. So I hope you understood how to do that question. So now we'll go to the next question. Okay, so this is the question. This is NLM. This is an LLM. Sorry, NLM. NLM question, but I think it can be done by work power energy too. I think, yeah, you can actually do it by work power energy too. I'll do it by NLM. So we know F is equals to MA. This is the name of an exam also. First, let's solve the question. Okay. So a lot of people marked 2 mg in this question apparently, which was, I don't really know how. I think, yeah, I know probably why they did, but I don't know. Okay, so a stone of mass m falls from height h on a soft, muddy ground. Okay, so it falls from a height h on a soft muddy ground. It's got on soft muddy ground. It sinks to a depth of h by 2. So after falling down, it sinks to h by 2. So that means like the ground is soft, so it just goes inside, right? So, okay, assume that the mud exerts a constant resistive force of magnitude F. So when it goes inside, let's say this is A, this is B, this is C, there is a resistive force acting on the body. Okay, take it. It's dropped, so it falls. So U is equal to 0, V is equals to root 2 GH. Now, how it is root 2 GH? You should be knowing V square is equals to U square plus 2 GH. So you just take the root and done. Okay. So we know V is equals to root 2 GH. Now what can we do here is, sorry, what? Yeah. So we can find, now we can go and find so now it says that it, 600 H. Yeah, so it will come to rest after that, right? So let's say this is V1, so V2. So we will say that V2 square is equals to V1 square plus 2GH. So GH की जगह हम बोल सकते हैं A होगा ना यहाँ पे accelerate, because the acceleration will be decreased and it will not be G because obviously there is a resistive force, so there will be a deceleration. So let's take it as positive only. So that is A into H upon 2. So let's cut. So this is 0. So we will get minus of 2GH is equal to AH. So A is equals to minus 2G. Okay, so we get this. So next, do I have space? Yeah, I do have space. Okay, good. So we got A is negative of 2G. So let's make a free body diagram for this, or let's see the forces that are acting on the body. So we will say the force, we will say its weight is taking it down, and that there's a resistive force. We are applying it from B to C. I think I'll show you. So this is B, this is C. We are now applying from here to here. Obviously here it will fall a distance h. Now we are seeing what will happen here. Okay, we have to find this force. That's it. Okay. So now applying from B to C, we know A is equals to minus 2G and W minus F is equals to M into A. We know this. Why we know this? Because like I mean obviously it's like F is equals to MA. So F net is equal to MA. So net force acting on it is W minus F resistive. Okay. So W is obviously mg and resistive force we have to calculate, and that will be minus 2 m g, right? Now you might say that the answer is coming out to be okay, sorry. So we get F resistive is equals to 3 mg, and that is literally the answer. So that is how you solve INJSO question. It's just pretty easy, I guess. To be honest, I think you can solve it by work per energy. Sorry, work energy theorem also. Let's see if we can do that. So we know that work by all is equal to delta K. So let's simply apply it from A to C. So this is A, this is C, this is H, and this is H upon 2. Okay. So work by all is the work by gravity plus sorry, minus the work by the resistive force, that is F dot S. So minus F dot S, and S is obviously this distance because the force acts from here to here. Okay, delta K is 0 because here it was 0 and now also here is 0, so that's 0. So work by gravity is mg into, that is 3h by 2. It is equal to F into h by 2 because it's only acting from here to here. So if we cancel this, we get 3 mg is equal to F. So the question gets solved in like what, 1, 2, 3 lines. So 3 lines we can solve this question also if you just go by work per energy. So that is another way to solve this question. I hope you like this session. I'm giving a homework assignment for you from this INJSO paper. This is a question of optics and this is of number of images. You might have done this already, like similar kind of questions, and you might think it's a pretty easy question, but you will find it pretty, like if you haven't done this kind of question, you will love it. Also, do not read the hint unless you are confused. Okay, so I hope you enjoyed the session. I will be ending the session now, but I forgot how to end it. Okay, yeah, this